Installing GitHub runners into your Kubernetes cluster using ArgoCD. First, we're going to find the Arc repository, the Actions Runner Controller repository, and copy it. We're going to go to ArgoCD and log in. Now that we're in ArgoCD, we can create a new application, and we're going to call this one HomeLab GitHub Controller. Create a project name, call it GitHub, and then we're going to set it to automatically sync in self-room. We're going to paste the repository URL that we had before, and now we're going to select from the path the GHA runner scale set controller. We'll set our cluster URL, and now we're going to set a namespace. We're going to set this namespace to be the same as the application name, which will make things simpler in later steps. Now we're going to go ahead and create this. And it's starting to spin up already right here. This will fail due to the custom resource definitions. When it fails, you're going to go ahead and just replace with a resync. And then it'll work just fine. So I'm going to go ahead and queue that up now. No, I'll wait so that you can actually see the error. The next step is to go ahead and create the actual set of runners, which need to be in their own namespace for security reasons. We're going to call this HomeLab Runners. We'll put this in the GitHub project name as well. Auto create namespace, and the same thing, sync automatic, self-heal, and prune. This is the same repository, and select the GHA runner scale set. We'll set our cluster, and then we'll call this HomeLab again. Now we need a URL for a repository. In this case, I've created a repository called HomeLab on GitHub, and this repository I've pre-populated with a Docker file and a workflow file that builds the Docker image. This Docker file is set to run on HomeLab-runners. And that is why we named this HomeLab Runners. If we named this anything else, HomeLab Runners-2, for example, we'd have to go and update this right here in the build script to HomeLab-Runners-2 example. So we're going to go ahead and set the GitHub config URL to the HomeLab URL. Now we need a GitHub token. Before I do that, I also need to specify two variables right here, controller service account .namespace and controller service account .name. These were created by the controller service that we installed, and since I named them both the same thing, the application name and the namespace name, I can just use the namespace name for both of these right here and be assured that it's going to work. But the final thing I need is this token. For that, I'm going to create a personal access token, and I'm going to add the repository, the write packages, and the admin org. Although I found I don't need write packages, I'm going to include it anyway. Give this a name. I can change the expiration date to never if I don't really want to deal with updating it, though obviously that's not the most secure thing to do. And generate token. Now I'm going to copy this token and go back to ArgoCD. And I'll paste the token into the field there. Now if I look down at the bottom, I've got all four of my configured variables set, and I can create. Now the HomeLab runners objects are spinning up. Now it's completely spun up, and you can see this ephemeral replica set ready to go, or runner set, I guess they're calling it. So next I'm going to switch back to GitHub, and you'll notice that the runner skill sets, the HomeLab runners, is now online. I've got two runners because I tested this before. Now if I want to run this build here, I can hit rerun jobs, rerun all jobs. And it should start to build now. Alright, if I look at ArgoCD, I can see some things happening. 2 ephemeral runners are being created. Now it's actually spinning up pods for the runner workers. The build has yet to start, but it should start soon. Once these pods are cached, it'll be a lot faster starting in the future. Alright, it appears the runners have actually started working. And it has finished a build. There was an error. By default, Buildkit uses the Buildkit namespace in Kubernetes to deploy workloads and build things. We're seeing a permissions issue with the Buildkit namespace, saying that our no permissions service account doesn't have permissions. The quick and dirty way is to give it administrative permissions to the Buildkit namespace. I've created a role called Buildkit admin that has access to all the resources in the Buildkit namespace. Then I need to create a role binding that namespace to the service account in the home lab runner's namespace. This role binding will live in the Buildkit namespace, and it will link to the role of Buildkit admin. Let's see what actually happens when a build is run. We're going to rerun all jobs from here. We're going to watch over in ArgoCD. You can see things already starting to happen. It's spinning up pods and the build is about to start. The build started, and then it's going to run. You can see it's running on the home lab runners right here. These names should match. There we go. DR42D matches. So I'm going to go ahead and set up the Kubernetes driver with BuildX. Wait for the pod to become ready. And that's ready. Now it's going to actually build the Docker image and then push it to GitHub. I will pause this for a second and let it complete. Now the job's cleaning up. Let's watch what happens over in ArgoCD. I really thought that'd be cleaned up by now. But this will eventually clean itself up, and all we'll be left with is this. Any day now. There it goes. I can go back up and check the registry. And we have our OCI image ready to go. That was built from this Docker file right here. Using this workflow. the main modification is to set this runs on. And be aware that the Docker commands in Kubernetes don't work like they would on a regular Ubuntu runner. While we're here, why not do a quick overview of the build script. On every push, we're going to run this build job on home lab runners. We'll give it 10 minutes to complete. I am not sure what outputs is doing here because I don't use that. Now we'll go through some standard steps. We're going to check out the repository. We're going to log into the container registry. We're going to set up Docker buildx using the Kubernetes driver. And we can give it mirrors just like this, although this mirror here doesn't actually work. This is where something like Harbor might come in handy. We'll extract some metadata for Docker, and we're going to go ahead and build and push the image. And thank you for watching. Someone give me a job!